All right, in this final part of our week 5 material, we're going to look at how to format strings cleanly. This is an important skill to have that maybe is not emphasized as much as it might be. Back in my first job for a consulting company in the previous century, I was required, to my dismay, to write Fortran code about things like oil slicks and dispersions of pollutants in rivers and ocean water and such like. And we had to produce reports in tabular form of various numerical information. Fortran is hideously unfriendly as far as making it easy to format material into reports, or maybe I should say it's friendly if you don't want to do anything very interesting. It's friendly if you're okay with defaults and you don't want to try to make your stuff look good. And I was very dissatisfied with this and spent a lot of time learning how to cleanly format information into reports. And somewhat to my surprise, it made a big impression when we met with our client, which was the EPA at the time. People remarked on how easy to read the reports were and how clean they looked. So that taught me that, this actually matters. If you have an opportunity to make a positive impression on your customer or your client or your boss or your colleagues, take that opportunity, and learning how to format strings in a very clean way is it matters. It's one of the things that matters. Normally when you format information into documents, you can hope that people won't care about your formatting, but sometimes you can actually annoy them if you format things badly. Okay, so there's my little soapbox sermon for the day. Let's get into how to do formatting of strings. Now Python is old enough, Python 3.7, that there have been various different approaches for formatting strings developed over the years. Because Python is an open source project, and because everybody believes that they can do things better than everybody who came before them, it turns out that there are actually 4 different generations of capabilities for formatting strings in Python. And we are not going to try to cover all 4 of these approaches. There's an enormous amount of redundancy in capability among the 4 different approaches. We're just going to concentrate on something called the format function that you can apply to string objects to format integers, floating point numbers, strings, booleans in a clean way when you display these things. All right, so here is one example of something called a format string, which contains these embedded format specification codes within it. And here is the dot format method being applied to that string. There are 2 format specifications in here, beginning with this curly brace and colon. And so as arguments to the format function, we have 2 arguments. The first of these is an int argument. The second is a float argument. Let me go ahead and type this thing in manually, and we'll talk about it as I go. I'm going to say s gets. Let me back up briefly. So here's s. We have this left over from the previous section, and we've talked about invoking methods on s. s.count of a, s. Find s. So we say the name of the string, variable, and then a method. We can just invoke these methods directly on an ordinary string. So if I say hello world, I can count the occurrences of L in that literal string hello world. I can say hello, how are you, and invoke the title method on that literal string to get each letter in each word capitalized. So that's what we're doing here with the format method. Let me type it without doing the ascets part first. So we're saying curly brace colon. Okay, curly brace colon is a way of introducing a format specification in a string. What I would like to do is to display in a 6-character wide field a base 10 number. D is a format code character, and D stands for decimal, as in base 10. All right, so this format specification here, curly brace colon, that just sort of initiates the format specification. 6D means that I want a field that's 6 characters wide, and I want a decimal or base 10 integer to be put into that field. Now I'm just going to type a comma. That's going to be treated as an ordinary character because it is not contained within the curly brace colon close curly brace so-called format specification. In fact, let me also put a space in here. No, actually I want to leave that space out. So now we'll have our other format specification, and this time we're going to say colon 7.2f. Now, curly brace colon, once again, introduces the format specification notation. 7 is my field width. This additional notation here, .2, means that I want 2 digits to be displayed after the decimal point. And this time, instead of a decimal integer, we're going to print a fixed point float. Fixed point means that a decimal point is going to be displayed, but no exponent is going to be displayed. Okay, so there is my format string, and now I need to provide to the .format method an integer value and a floating point value. Okay, and the result of .format here is a string. This first argument, 1, 2, 3, that's an integer value, an int. That argument is taken and formatted as a base 10 integer in a 6-character wide field. By default, I get spaces to fill out the beginning of that field. Integers, it turns out, are right justified by default. Okay, so what I get out is space, 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 1, 2, 3 for my 6 characters. Here I have the literal comma that I typed that is outside of a format specification, so it's just displayed as is. And then I have a field that's 7 characters wide. 1, 2, 3, 4, 5, 6, 7. 3 of those characters are spaces. The remaining characters represent the value of 7/3, but only out to 2 digits after the decimal point. So I have 2.33 after the decimal point rather than 2.333 or 2.3333 or whatever. Okay, so curly brace colon 6D close curly means specify a format that is 6 characters wide for a decimal or base 10 int value. And integers and floating point numbers by default are displayed right justified. Then we have a literal comma that's just displayed as is. And then we have a 7-character wide field. in which we're going to have 2 digits after the decimal point. This is going to be a fixed point number. That is, it's a floating point value, but there's no exponent displayed. And so here we have 1, 2, 3, 4, 5, 6, 7 total characters. Sorry, I don't mean to don't mean to highlight that quote mark. There we go, got it. So here are these 7 characters of output, space, 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 2.33. So there's a decimal point, and there are 2 digits after the decimal point. And there we are. So that's a first simple example. Now, on slide 2 here, we also have a less than symbol in front of the 6D. Let's see what happens if we change that to a less than symbol here. That is, if we put a less than symbol in front of the 6. The less than symbol you can think of as being like a pointer to the left, a left arrow. And what it says is that I want to left justify the integer rather than right justify the integer. Right justifying is the default. This time I'm going to left justify. And so now I get 1, 2, 3, space, 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 instead of space, 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 1, 2, 3. Notice for the floating point value in the example on slide 2, we have a greater than symbol, which you can think of as pointing to the right. And that would give us right justified output for the floating point value as a fixed point number. But here we don't see any difference because right justified output is the default for numbers anyway. All right, so there is a brief sequence of little examples of using format strings. Now, basically, this format facility found in Python comes from similar notation originally developed in the C language in a function called printf for print formatted. And the way you use it is you specify a format string. That format string contains a collection of format specifications using this curly brace colon notation. And for each format specification, you have to provide a corresponding argument of the correct data type as an argument to the format function. And what the format function will do is to format in each of these values into the corresponding format specification and return a stir object that has been formatted according to that format string. Now, in the little examples we've looked at so far, we've used D for decimal integer and F for fixed point, floating point number. Fixed point, as I said, means to display a decimal point but don't display any exponent part. A couple of other formats codes that we can use are S if we want to plop a string into our format specification, or E if we have a float and we do want to display an exponent. Okay, E is for exponential, whereas F is for fixed point. And if I use the E format code, I will get an exponent displayed. Let's try that one first. Let me just add in here, or change in here, the F to an E. Now, the output that we get here is actually too wide. It's actually wider than 7 characters. So what happens if you ask to display something in a field that's 7 characters wide, but the result is actually too wide to fit? The result will be displayed in as few characters as possible. So what we have here is 2.33, because I did require 2 digits after the decimal point. But I also used e here, which means I require an exponent, and the exponent is displayed as e followed by a plus or minus sign, followed by a minimum of 2 digits of an exponent. In this case, the exponent is 0, so this is 2.33 times 10 to the 0 power, but I do get 2 digits for the exponent. Instead of this, sorry, whoa! All right, didn't want that. Let's try this again. Let me copy and paste this whole thing. And instead of a 7-character wide field, let's have a 10-character wide field. This will be a little more interesting, or this will be able to be formatted correctly because I've specified a field that is wide enough. Okay, so I have my first format specification is curly brace colon, just kicks off the format specification for the first argument. I want a left justified 6-character wide field for a base 10 integer, a decimal integer. And that displays 1, 2, 3, left justified in a field 6 characters wide with spaces filled in on the right side. Then we have our literal comma. Then we have, as our next format specification, okay, curly brace colon just kicks off the specification notation. Right justified, we want a 10-character wide field in which we have 2 characters after the decimal point with an exponential format, that is an exponent displayed, and this has got to be a float in order to work correctly. And now we have 10 characters wide. Space, space, 2.33, so that's 6. E plus 0, 0, that's 4 more. So we've got a 10-character wide field with a decimal point and an exponent displayed. Now the value has to match the format code. It has to be appropriate for the format code. So if I say this, curly brace colon 5D, and then I say dot format 4/7, I'm going to get yelled at because 4/7 is a float, and D is not a format code that will work for a float. D only works for integer values, int values. All right, here I have a little bit longer example. And again, let me not bother assigning this to S, at least initially. We'll say, whoop, got my quote first. Okay, curly brace colon, this is going to be my first field specifier. And I want to display a decimal integer. I have not specified a field width there, so the decimal integer is going to be displayed in as few characters as it requires to be displayed. Then I have a literal comma space. And the comma space is just going to be displayed as comma space. My next format code or format specification is curly brace colon S, and then close curly brace. So that's going to be a string. The second argument to my .format function is going to need to be a string. That string is going to be displayed in as little case, in as few characters as possible, as necessary. And then I have a couple of dashes. These dashes are just ordinary characters that are going to be displayed. My next value is going to be a float displayed in fixed point, a fixed point output, meaning that there will be a decimal point, there will not be an exponent displayed, and the corresponding argument must be a float value. Then I'm going to have a colon space, that's just literal characters, and then colon E for displaying an exponent as part of my float result. Okay, so there's my format string containing 4 format specifications. And in these format specifications, my format codes indicate that I want to display a decimal or base 10 integer, a string, a fixed point float value with no exponent, and an exponential float value with an exponent. Now I'm going to say .format. And because I'm running out of space, because I've just typed an opening parenthesis, I can go ahead and hit the Enter key now and just keep going. Let's display 123 as the integer, hello as the string, 7/3 as the first float value, and then 7/3 again as the second float value. Okay, so what did we get? All right, well, we got 123 displayed as a decimal base 10 integer. And 123 only requires 3 characters to be displayed, and so it's 3 characters wide, 1, 2, 3. Then I got my literal comma space. Then I got a string and as few characters as required. The string here is hello, so that comes out as just hello. Then I've got my 2 literal dashes. Then I have 7/3 displayed as a fixed point value. And here it is, 2.333333. Okay, so I did get a decimal point. I did not get an exponent. And it turns out that the default precision, when I say that I want to display a fixed point output of some float value, by default, since I didn't say otherwise, I get 6 digits after that decimal point. Then I have this literal colon space. Following that, I have the exponential representation of 7/3, and it comes out as 2.333333 with the exponent e plus 0, 0. So, in other words, 2.333333 times 10 to the 0 power. Okay, so since I did not specify, .2 or .5 or .9 or some other precision value in my format specification, I got 6 characters after the decimal point by default. Okay, so we have format codes for displaying integers, strings, and floating point numbers. And there's some other ones that I haven't shown. Let me just show you one more, just to show you what I mean. We are mostly going to want to look at integer values in base 10. That's what people are used to. But you could, if you're somebody who is comfortable with the hexadecimal number system, the base 16 number system, you could say something like :x dot format of, let's say, well, 16 is a good example. All right, if you display 16 in base 16, what you're going to get out is a 1 and a 0. That is, there is a 1 in the 16's place and a 0 in the 10's place. If I say to display as a hexadecimal value .format of 255, this is the largest integer value that can fit into 8 bits in your system. And so it turns in hexadecimal to FF. That is, it's 15 in the 16's place plus 15 to correspond to a decimal value of 255. All right, so if you're not into hexadecimal numbers, don't worry about that. For hexadecimal numbers are used a lot by computer scientists, but not typically used that much by business people or medical people or statistics people or what have you. So you can almost certainly live without memorizing :x. Okay. Now, so we have format codes for displaying ints and strs and floats, but we've got two other low-level data types that we might have to worry about. Namely, we've got none and bool. There are no format codes in this style of format specification for handling the special value none or for handling Booleans. And the reason, very simply, is that when the C language was developed and the printf function was developed, the original C language had no concept of none or Booleans. The value 0 was simply used to keep track of non-valid addresses and things like that. And in C, 0 is used for false, and anything other than 0 is used for true. So there were no format codes in printf to use for none and bool, and similarly or consequently, there is no format codes for those in the Python format function either. However, all is not lost, because you can convert none to a string by just using the str conversion function if you wish, and that will enable you to display the characters NONE. And then for Boolean values, you can either convert Boolean values to an int. True will be converted to 1, false will be converted to 0. Or you can convert Boolean values to strings, in which case true will be the word true and false will be the word false. All right, so in this example here, we're saying let's print a string and then print a base 10 integer and then print another string, and the values to be plugged into those format specifications will be none converted to a str, true converted to an int, and false converted to a str. All right, so there we are. So we have none converted to a str and then displayed as a string. So that's just these characters NONE. Now, notice that I don't have any characters between the :s format specification and the :d format specification. So that means that there's going to be no characters in the output between what's displayed for none and what's displayed for true. If I convert true to an int, that has the value 1, and so 1 in base 10 is what's displayed. Following that, again, I have no characters between the :d close curly specification and the :s. So false then is going to be displayed as a string. So none, 1, false, all combined together, all concatenated together, is what's displayed by that format string with those format argument values. Okay. Now, as we saw in the early couple of examples, in between the colon and the format code character, which might be a D or an E or an F or an S or X for hexadecimal or various other things, if you wish, you can put in a field width, and then at least that many characters will be displayed. And so here I have some examples of fields that are 3 characters wide and fields that are 15 characters wide. Let's take a look at this. I'm printing a table here. I'm using a for loop. So for k in range 5, so that's going to be 0, 1, 2, 3, 4. Let's print, and here's my format string. All right, now we have a 3-character wide base 10 integer, followed by a comma, followed by a 3-character wide string, followed by a comma, followed by a 15-character wide fixed point number, a floating point number with a decimal point and no exponent, and then a 15-character wide, whoops, forgot my colon, 15-character wide exponential value. So that's going to have a decimal point and an exponent. Format, open paren. All right, so I've gotten out to typing my open paren. Now that I've made it out to my open paren, I can go ahead and press the enter key and keep going. And what I'm going to display is, well, let's see. K is going to be taking on the values 0, 1, 2, 3, 4, one at a time. So let me just display K as an integer in a 3-character wide field. Then let me display K converted to a string in the 3-character wide string field. Then let me display K sevenths. Now an integer divided by a number is going to be a float. And also let me display K sevenths again. So that's another float. All right, that parenthesis closes my .format method, and another parenthesis concludes my print function. Now, in my output, the first column of output is 3 characters wide, and it's a base 10 number. So by default, that base 10 number is right justified, meaning that there are 2 spaces in front of the 0 and 2 spaces in front of the 1 and 2 and 3 and so on. It turns out that when you display a string, rather than being right justified as numbers are, a string is left justified by default. So when I display this integer converted to a string as a string, it is left justified in the output. So I have 0 space space to fill up the 3 characters that are required for that :3. And then 1 space space, 2 space space, 3 space space, 4 space space. So numbers are right justified by default. Strings, it turns out, are left justified by default. Then we have K sevenths displayed in fixed point notation and in exponential notation in 15-character wide fields. The default precision is 6 characters. Okay, I've specified a field width by saying :15f and :15e, but I have not specified a precision size. So I get 6 digits of precision by default, and so I'm going to get 1, 2, 3, 4, 5, 6, 7 spaces, followed by 8 digits and a decimal point. So there's my 15 characters for my floats. Now, for the exponential output, because I have a 4-character exponent on the end here, e plus 0, 0, e minus 0, 1, and so on, I only have space left for 1, 2, 3 spaces at the beginning. So I've got 3 spaces, then I've got 8 digits and a decimal point, so that's 11. And then the 4 more characters for the for the exponent part, the 4 characters for the exponent part gets me up to a total of 15 characters wide. Okay. And 0 is just represented as 0 times 10 to the 0. Notice that these exponents here are 10 to the minus 1 because in exponential output, you always get 1 digit ahead of the decimal point. Then you get any additional digits after the decimal point, and the exponent is adjusted to whatever it needs to be in order to make that number be correct. So the actual value of 1/7, you'll agree with me that 1/7 is less than 1. The actual value is 0.1428571, etc. But because we require one digit ahead of the decimal point when we ask for exponential output, instead of being displayed as 0.14285, it's displayed as 1.4285 times 10 to the minus 1. Okay. Then, next up, I already described a couple of these characters. We can use immediately following the colon. We can use a less than symbol if we want to left justify the output. We can use a greater than symbol if we want to right justify the output. It turns out we can use a caret symbol or hat or circumflex symbol, whatever you want to call that guy, an up arrow, if you want to center the output. So just for gags, let me do the same for loop. I'm going to copy and paste this. But instead of accepting the default justification, which is left justification for strings and right justification for numbers, let me center everything. So I'm going to center the integer, I'm going to center the string, I'm going to center the fixed point output that doesn't have an exponent, and I'm going to center the exponential output that does have an exponent. The total number of characters displayed is exactly the same as it was before, and in fact what it is 3 plus 3 plus 15 plus 15, so that's 36, plus space for these 3 commas. So each of these lines is 39 characters wide, but each of the fields is centered. So I've got space 0 space for the integer, space character 0 space for the string, then I've got space 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 followed by 8 characters followed by 4 spaces for the fixed point expression. Now, I have a 15 character wide field, but the number of digits and decimal point that need to be displayed is 8. That means I've got 7 spaces, and Python's choice is to put the extra space after the value rather than before the value. So when I have an odd number of spaces to display for centered information, I get one fewer space in front than I get after. So in this case, 3 in front, 4 after. And then here I have 1 space in front, followed by the number and its exponent, and then 2 spaces afterward. All right, so there's my 39 characters of output in each of those output lines. Furthermore, in the case of float values, and this only applies to float values, it doesn't apply to int or stir values, you can additionally specify a decimal point with the precision, which is the number of characters after the decimal point that you want to see. So here we have, okay, let me just do these examples. I can copy and paste these guys fairly easily. Let me do that, and then we'll talk through what they're up to. This time, I'm only displaying int values. Whoops. I pasted the wrong thing, so let me delete that and we'll try this again. I must not have hit Control-C correctly for this, so let me highlight this again and press Control-C. Hopefully it took that time. There we go. Now, it didn't copy the indentation properly, so let me make sure that print is indented. And actually, because I'm inside of a parenthesis here for format, this next line down, it doesn't really matter what the indentation is, which I know seems strange that for some reason Python doesn't care about the indentation inside of parentheses or square brackets. But hey, I didn't design this mess. There we go. So now just to make things look pretty, I've indented that stuff as well. K is in the range up to but not including 3, so 0, 1, and 2. And what this example is illustrating is no justification. That is, I have not specified any justification for column 1. And then I'm specifying left justification, centering, and right justification for columns 2, 3, and 4. And what we see is that if I don't specify what justification I want for a number, I get right justification by default. And then if I do specify left or centered or right justification, then that's what I get. So left justified, centered, right justified. That's for ints. Now here's for, this next example is for floats. And this time I'm doing just one line of output. I don't have this wrapped inside of a for loop. And we're displaying some literal vertical bar symbols here just to separate the fields from each other. I guess we did that up here as well. I just forgot to point it out. These vertical bar characters are just literal characters that come out as separators between the columns. All right, so when I hit enter here, I have the default justification for a float in the 17-character wide field. And the default justification is right justified. I've asked for just 2 characters after the decimal point. And so that's all I get. I got 2 characters after the decimal point. Total, I have 4 non-spaces of output here, so that must mean that there are 13 spaces here. And I could count them, but let's not bother. Here I have left justified output, so this time I have the 4 characters first, followed by 13 spaces. And here I have centered. So this means that I have 6 spaces and my 4 characters, and then 7 spaces to fill out the 17 characters in that column. Okay, and then this final example on this slide is basically the same idea, except that we're asking for exponential output rather than fixed point output. And I've requested 9 characters after the decimal point rather than 2. Remember that the default number of decimal points is 6 if you don't request a specific number of decimal points. So here I'm asking for 9, which is more than I would get by default. Okay, and so because I'm asking for 9 characters after the decimal point, that means that there's a total of 11 digits plus decimal point displayed, 4 characters for the exponent, which means that there's only 2 characters in front. Okay, so I get left justified by default, right justified if I ask for that, so that means the 2 spaces are at the end, and centered if I asked for that, so that means I've got 1 space in front and 1 space in back. Okay, so now we'll have a lab which will give you some practice with these things. Now, this seems like a shocking amount of detail to have to remember, but in fact, the structure of all of these format specifications is relatively simple. Let's look at this particular example here. Whoops. you start out your format specification with curly brace colon. Then, optionally, you can specify a field width if you wish. If you're displaying a float, you can optionally specify a precision if you wish. And then you have your format code letter, which is either D, F, E, or S. And I forgot to mention that you can also have a justification in here. Left justify, center, or right justify immediately following the colon. Okay, so that's the basic structure. Do you want a format specification? Yes. So colon, curly brace colon. All right. I have a specification. How do I want this output to be justified? Let's see. Let's suppose I want it to be right justified. So I'll say greater than. How wide do I want the field to be? Let's say 10. Now, what am I printing? Is it an integer, a string, a floating point number? If it's an integer, I just say D and close curly, and that's it. If it's a string, I just say S and close curly, and that's it. If it's a float, I can say either F or E, and that's it. Or if I wish, I can also specify a precision, let's say 4, with either E or F. Now, I don't know why it displayed that help stuff for me. Okay, so dot, and then the precision, and then either E or F, and then I'm done. So you have really quite an extraordinary amount of power for formatting these values of various different types in a very, very precise way by just learning this structure of format specifications in format strings with the .format command. With the .format function, excuse me. And I do strongly urge you to devote some time to memorizing this little structure, this little bit of notation, so that you can create output that's very precisely formatted in exactly the way that you want it to look. This format syntax with these format specifications will not directly handle every conceivable case of wanting to format values that you might encounter, but it will handle, I'd say, about 99% of situations in a very straightforward way. You can learn all the other ways that Python provides for formatting information at your pleasure and convenience, but if you know this one mechanism, you'll be really set for very precisely formatting your output in the way that you want it to look. Okay, so there was my second little soapbox speech. All right, and so we're done, and you'll get some practice now playing with the format.